Hey, and welcome back to the final session. Thank you for your stamina and energy staying with us since 11 this morning. We are now going into the final session where we're going to do a quick lab together. So enough talking, just a lot of hands-on. So as you can see on the screen, if you have not already, go to google.qwiklabs.com to sign up for an account if you haven't got an account. Because once we get started, you don't want to fall behind because you haven't got an account set up and all that. So I'm going to leave that page up a little bit. So go to google.qwiklabs.com, sign up for an account, which is really quick. Then they'll send an automated email to your inbox. Click on that to verify that who you say you are, and then you have an account, and we can get going. So don't worry, just quickly go and do that now. For the next 5 minutes, I'm just going to talk a little bit about Compute Engine, what we're going to cover today, and then I'm going to jump into the lab. Right. So here we go. So today's OnAir event is all about Compute Engine and a specific service in GCP, Google Cloud Platform. You have heard all the speakers talk about all the unique features, so I won't repeat them, right? Except to maybe to highlight a few things that I've seen in the field that's really, really popular. For example, we can do custom VMs. A lot of, we do have stock standard templates where you have 1 CPU, 2 gig of RAM, 2 CPU, 4 gig of RAM. But what if your configuration is a little bit unique? Because your workload could be compute intensive, therefore requiring less RAM, or your workload could be memory intensive, needing more RAM but less compute. So in the chart on the right of the screen that you can see right now, if you want 104 gig of RAM for your VM, right, the stock standard template will require you to have 16 vCPUs. But in the earlier example that I mentioned, if your workload is memory intensive but not CPU intensive, by going the custom VM route, you can remove 8 vCPUs from your configuration, therefore saving you cost. So your workload still runs without any performance degradation, but you're saving quite a bit on a month-to-month basis, as you can see. So that's a unique feature in GCP. Another unique feature is live migration. So don't worry if there's any patching or security or hardware that needs to be done. We will not schedule downtime on your behalf or ask you to schedule downtime. We'll simply live migrate your workload from the physical machine is on to another physical machine seamlessly. Right, so that is done automatically, and your application won't even notice it. That's another unique feature here. The third one is, what about Windows, SQL Server, and all the Microsoft stack of products and software stack? We do support them. In a lot of our labs, including today, we are using Linux because they're small, they're quick, so we're just able to demonstrate capability. But you can bring your Microsoft Windows and SQL Server workloads to Google Cloud Platform. And the advantage here is that the images are pre-engineered by us, pre-tested, pre-patched, and also performance-tuned for our platform. And you can do a pay-as-you-go, meaning that the moment you spin up a Windows VM, you start paying for the Windows server license, so you don't need to bring any licenses. Of course, there's also the option of you bringing your own license, and that's get into a lot more detail, which we'll not cover here, but it's available. All the details are available on our website. Right. We're getting closer to doing the labs now. So one of the things that you've been hearing about is this global VPC, a virtual private cloud. Now we have over 20 regions around the world. Every region have at least 3 zones for redundancy. So you have a lot of options on where you want to put your VMs, your cluster of VMs, or you have clusters of VMs that work together that forms the part of your software or your service that you in turn externalize to your customers and partners. So now there is a lot of options here. So in fact, the first lab that we're going to do very, very shortly is I'm going to show you how to quickly create a software-defined VPC network with firewalls set up with 2 VMs. The 2 VMs are completely identical, and they are put in different subnets within the VPC, but the only difference is the firewall rules that apply to them. And then we see what are the implications. Now, this is a very simple and basic setup, but it introduces you to the fundamental concepts of networking, because if you have a VM and you don't really know how to make use of the software-defined network, then it's kind of hard for you to define policies and then expose your service or expose the right service to the right VMs and of course to the external world. Another interesting, very unique feature of Google Cloud is that the notion of global load balancing. Now, when we think about load balancers, we always think about, I need to set up more servers, I need to have more redundancy, I need to have more clusters, what do I do with IP and all that? So by coming onto Google Cloud Platform, we actually alleviate you from that worry and that planning. We have what we call a single IP global reach multicast load balancer. And in the second lab, I'll be doing that, which means that I can put my workloads in any major region around the world. Depending on who is requesting for that service, we will figure out the closest region that has that server or cluster that's ready to fulfill that request, and we will route that request accordingly. So in this diagram, Maya is hitting your website, and Maya is in North America in California, and we will seamlessly route her to the nearest service, which is in US West 1, West Coast of US. Similarly, if Shen from Singapore is asking for the same service of your website, our load balancer will sense that he is in Asia and will route him to the nearest cluster, whether that cluster be in Singapore, or if that cluster is not in Singapore, we route him to the next closest cluster. And of course, that means that we are going to do a lab. I'm going to show you quickly how to do this as well. Right, so enough talking. Let's go and let's get started with the Qwiklabs setup. Now, you would have already set up your account, right? So here we go. We need you, we are giving you access code to Qwiklabs. So Qwiklabs is not free. 1 credit is equals to $1 depending on the labs that you do. The different labs have different costs. And I'll explain a little bit why we charge money for that. You'll see it's quite apparent later. But because you sign up for this this live event, we're giving you a free access code. Without further ado, here is the access code. I'm going to leave this screen up here for a while. You can do a quick screenshot capture if you like. But as I progress along, this URL and this code will be available as an overlay over this video as well. So that's the URL you're supposed to click, and that's the access code, right? So I'll just give 2 more seconds for you to take that screenshot. Okay, so here's what's going to happen. I'm going to exit out. Let me go ahead and click on the link, Control C, and I'm going to go to this page, open a new tab, put in a link. So follow along with me, right? So this is a unique URL, and therefore it asks you for an access code. Now, what's the access code? Is 1B, because not that I have got good memory, but I think I've rehearsed this yesterday, so I remembered the code, so 389. Right, so 1B-DIGCON-389, you got to click on I'm not a robot. And this is a part where potentially, it works, okay, I'm not a robot, it believes me. Click submit, and you're in. Now, the only difference is if you're doing this for the very first time, this little red bar on my page should be blue because you have not enrolled, right? If this is the very first time you're coming in, putting in the access code, we need you to click on the blue bar, which is where the red bar is, and then you enroll. And then we can go ahead and do the second lab, right? So that's what we're going to do, right? So let me go back into my presentation. And that's the link and the access code one last time for you to do a screenshot or memorize it. Right, so as I mentioned before, click on the blue button. You enroll yourself into that quest. That quest has a number of labs. We're only doing 1 lab in that quest today, right? And this is a part where if you click on that link and you didn't pre-sign in to Qwiklabs, you will see this. But if you already have an account, you click on that little already have an account link at the bottom, right? And for final piece, when you're about to start the lab, when you click on the green button to start a lab, a little pop-up will come up and tell you how much that lab costs. Now, because you've entered the access code previously, you have a valid subscription, which is written there on the screen. You have a valid subscription. Would you like to charge this to your subscription? Click yes, or rather use subscription. And then you get free access to the lab, right? So without further ado, let me switch back to the thing, and then we're going to do some hands-on. Let me roll up my sleeves a little bit. Okay, here we go. All right, okay, so we're here. We are going to click into configuring networks via Qcloud. Right? It will then load up the lab. Now, the lab materials is available 24/7. Every time you log in, you can have access to it. What you do not have access is the ability for you to start a lab. Now, because you have the access code, and this access code allows you to do labs for the next 30 days, right? So that's amazing. You can do as many labs as you want in the next 30 days. And on top of that, if I come back to this quest, which is where you enroll, if you finish every single lab in this quest, which is the 1, 2, 3, 4, 5, within the next 30 days, you get another 30 days free, right? So you get 2 months worth of Qwiklabs where you can really get skilled up, knowledgeable about GCP, and I've seen a lot of questions that are posted online today. A lot of those will be answered by going through all these labs, right? We'll come back to the labs, the overview of this later, but let's get into the first lab today, all right? So let me click on Start, all right, and say, yes, I'm gonna use my subscription, as you would. And then what's happening in the background now is that Qwiklabs is going to provision a Google Cloud Platform account and a Google Cloud project ready to go for the specific use of this lab. Now, this environment will be available to you for the next 1 hour. We will then use it and we'll see where we go. Apologies, my Google Assistant, a little bit noisy today. Okay, so that is running now. Okay, so it's taking a little bit longer because I think there are thousands of you who are signed up and we are all clicking it at the same time. So it might take a while to provision, right? But while that is provisioning, I have a plan. I will walk you through what's going to happen as we move on so we don't waste time here. I'm going to go into the lab material, right? Okay, so maybe the screen got mixed up because I already have an environment here. Okay, let's use this environment because I'm configuring networks via G-Cloud. I have started the lab. I have 59 minutes and counting down. No worries, we've got plenty of time today. What we need to do is to click on Open Google Console, right? So I'll click on that. So what you need to do next is to do a copy and paste of your username and password, right, into the Google Cloud Console. Now, your user ID and password will be different from mine because every one of us are creating a real GCP environment together. So let's see how it goes. Now, it may take a while because I just realized there are thousands of us doing this at the same time. Okay, so while that is happening, I'll wait for that page to load. We will then walk you through. I'm going to skip a lot of this because as I'm walking through and doing it and you're following along with me, you would have cleared the overview and the setup and requirements. And then we're going to go ahead and create our very first network, which is right here at this section called Create Network. Right. So what we're going to do is we're going to explore the use of Cloud Shell. And Cloud Shell was mentioned very briefly by Shaista earlier in the first session. And so, I can see the second page is loaded. Let's go in there. Okay, it's asking for my student ID. I'll click here to copy. Come back here, paste, hit enter. Then it asks me for password. Click copied, put in my password, enter. Now, because this is the first time, we have to go through all this. Yep, we accept my new account that's created. No, I will just click done. I won't want to update because within an hour, this whole thing is gone, including the ID. So there isn't a need. And we're in. And it's going to ask me one last thing to agree to terms of service. Now, depending on which country you're in, that country will automatically be selected there. So I'm in Singapore. I'll click agree to it. I don't want it to email me anything because, again, this account will disappear in an hour's time. So there isn't a need to do that. So click agree and continue. Once we're done with that step, we are now inside the project, as indicated here on the top. We're inside this specific project that's created for you for this lab for 1 hour, right? Now, as a way to speed things up, here's a little tips and trick here. So we're doing compute engine and networking, right? So instead of scrolling up and down and hunting for the menu item, there's a little pin button, right? So if you go look for compute engine under compute, click on the pin, and it comes up right at the top. right? So the next thing we want to do is we want to go down to networking and look for VPC network and click on the little pin, and it goes right to the top. So the next little tip and trick here is that we can open all this in separate tabs. So in Compute Engine, I'll just right click, I'll open a new tab. I'll go to VPC network, right click, open a new tab. Right, so let's inspect and see what's happening there. So in VM instances, there are no VMs there. Completely new project, nothing is created yet, provisioned yet, great. In VPC, oh, hello, we have a default VPC network with subnets that seems to span our entire globe. And that's by design, because we don't want you to go creating a VM without a network available, so we define a default network, right? But in this lab, we're going to create our own network. So let's get going. Let's go back to the lab. Okay, so we will need a Cloud Shell. How do we get a Cloud Shell up? That's very simple. You go to your console. There's this little icon there that says Activate Cloud Shell. Click on that. So Cloud Shell is, to me, is a productivity tool because I don't need to install the SDK on my laptop, whether be it Windows, Linux, or Mac, right? I'm using Chrome OS, by the way, if you haven't figured it out based on the UI. So the Cloud Shell is now running. It's now being activated. Sometimes you might want to have your Cloud Shell standalone in a tab of its own, right? So to maximize the screen. So that's what I'm going to do. I'm going to come over here and click this little up arrow button. And I create a new tab with my Cloud Shell in there. Yeah? Okay, so while that's loading, I'll come back here and I will minimize this one. So we get the full GUI view here. And then we got a Cloud Shell view. Now, we can increase the font size so that you can see what I'm doing. Let me go to the largest. Oh, that's a bit too big. Oh, that's a bit overkill. Maybe I'll just go large, or maybe medium. Medium is okay. Maybe I'll just go large. Can't decide. Okay, I'll go large. All right. Okay, so then it's a simple matter of copy and paste. Now, it is pointless to copy and paste without understanding, right? So what I'm going to do is for every command here that we execute, I'm going to show you how to do it using the GUI as well, right? So here we go. So I'm going to copy this command, right? And paste this command in here, Control V. Right, let's have a look. G-Cloud Compute Networks create LabNet, and the subnet mode is set to custom. So let's look at VPC network here. There's default and then nothing else. So what happens when I fire off this command? Right, off it goes. And usually this is really quick, so if I come back here and I do a refresh, I would see LabNet created right at the bottom over here. Now, this default is in the way, so let's go and delete the default. Click on default. And then I go delete VPC network. Now it will take a bit of time, maybe 60 seconds for the entire network around the world to be deleted based on this VPC, right? So you can see there's a little spinning circle, work is being done there. We have created a LabNet. Now, how would I do this using this GUI instead of the command line? So I will come up here, I'll go create VPC network, right? And let me call it LabNet2, just to differentiate LabNet2, right? We did say that we want custom, right? So not automatic, which means that it's not going to automatically create subnets on your behalf, right? So you have to go and create your subnets manually. So that's what it means. So I click custom. I'm not going to create a subnet yet, so I'll delete that. And then I say create. That's it. So that's what that single line over here does, right? So this single line created LabNet. Over here, if I click refresh, you will see LabNet2 is created, right? So now we're going to add subnets into LabNet, right? So let's go back to the lab, scroll further down. Oh, okay, check my progress, click on that. So this lab is going to go back into your environment and verify that you have followed the instructions correctly by inspecting your cloud project, and therefore you get a tick. So if you did not create that LabNet, you will not get this tick on this page. Next, we're going to create a subnetwork, right? So very quickly, copy this command, go back to Cloud Shell, clear, boom. G-Cloud Compute Network Subnet Create We call the subnet as labnet-sub, right? It is now part of the network called labnet. This subnet is in the region called US Central 1, and this is the IP range. I hit enter. If I go back to my VPC network page and I click a refresh, you will see labnet-sub is now created. Now, how would I do this on a GUI? Like if I go to labnet 2, let me repeat that step now using the GUI, right? So I'll add a subnet here. I'll call this subnet, what do you call it? labnet2-sub, right? It's part of labnet 2. The region, let's follow and be consistent and choose US Central 1, right? The IP is 10.0.0.0/28. And I scroll down and I click add. And that should be it. All right, so let me go back out and click refresh. Voila, right? I've just created a subnet in the VPC, right? I've shown you now both how to do it in command line as well as in GUI. Let's go back to the lab sheet and see what do we need to do next. Oh, verify my progress. Check. Tick. Oh, it's taking a while. Let me click on that again. Doesn't matter, let's move on. Things are a bit slow today. Now, here's a command to list your networks again. Why is this useful? Well, sometimes you don't have access to your web GUI. All you have is a command line, right? So you want to see what networks are available in your project. Now, because in your case, you would have already done one. In my case, for redundancy, I've created a second one using GUI. So I have two here, right? And then your output should look like that. Great. We can even have a command that describes the network. I'm just going to skip that. That we have a command to list the subnets. Again, we have the GUI, but if you don't, here is a command that lists the subnets. I should see two because one belonging to each VPC, right? Now, let's see. Creating firewall rules. Okay, this is the next part that's a bit more interesting, right? So I'm going to create a firewall rule. Let me copy that and put that into the command line so it has a bigger font and we can see what it's going to do. So G-Cloud Compute firewall rules create. The firewall rule name is called labnet-allow-internal, right? This firewall rules apply to the VPC called labnet. The action is allow. The rules is equals to ICMP and TCP/22. ICMP means that I can ping. So if I deny, even a ping request would not work, right? Port 22, as you know, in Linux is secure shell access. So we do that, and then we lazily put source ranges to every single IP in the world. Obviously, this is not meant for production use, but for lab teaching. So I'm going to hit that. So creating firewall rule. Now, where would the firewall rule appear in my console, right? So right next to it, there's a firewall rules under VPC networks, and you see labnet allow internal is set up. What if I want to do a firewall rule using the GUI, but now I apply it to labnet 2, right? So let's go ahead and create a firewall rule, right? I'll create a new one, and I'll call this, what did we call it previously? Labnet allow internal. Okay, so I'll do labnet2 allow internal, if I can spell it correctly. Internal. Okay. So the network that we're going to apply on is labnet 2. Okay. We're going to allow ingress, specific tags. No, we're not going to do the specific tags until we do the next lab. We'll come to that in a short time. Source ranges, again, very lazily, I'll just put everyone from everywhere. Again, not a best practice, but this is meant for lab. So TCP/22, and then other protocols, we want ICMP, right? And click create. Sorry. No, I don't want a specific, I want all instances. So this firewall rule applies to all instances in a network, not to a specific tag. This is probably a good time to talk a little bit about tagging. So because it's all software-defined networking, when you create a firewall rule, you can have the option of applying that firewall rule carte blanche to everything within a subnet, or you can set this firewall rule having a tag. So every VM that has that tag will follow that firewall rule. So it's like feels like a social media. I'm tagging my friends, but you're tagging VMs now. Sorry. Yep. The Qwiklab links are now on the screen at the bottom, if you can see them, right? Just in case you have missed that out, click on that so that you can get access to Qwiklabs, right? So the link is still at the bottom. We'll hold for a couple of seconds so you have a chance to click on that link, copy that link, or even take a screenshot. That's the most effective, right? Right. Okay, so let's get back to our regular programming. So now in this lab, because for simplicity, I want to apply this firewall rule to the entire subnet. So every VM that I provision in that subnet will follow this firewall rule. Now, if you are more sophisticated, and we do this, I do see this all the time, you're able to have multiple firewall rules correlate to a unique tag, and a VM can have one or multiple tags, and therefore that VM will follow whatever firewall rules that comes with that tag, if you see what I mean. All right, so that gets in a bit more advanced topic, but I just want to quickly mention that this capability is available. So I'm going to click Create Now on the screen. And very quickly, you will see the second firewall rule, which is identical to the first one. I just wanted to show you how you can do it both at command line as well as GUI. GUI is great for learning. Command line is great for automation. So imagine you have a bunch of command lines that you can string together in a script. You can very quickly provision an environment in GCP. Right? Therefore, we have these both these options. Let's go back to the lab. Okay, so now we've created the firewall rule. Click on that, check my progress. Tick, fantastic. So I'm going to skip this because, again, you can copy and paste this. This is basically viewing the firewall rules in the command line. You can do that in GUI as well. So what we're going to do now is, based on everything that we've learned so far, we're going to create a separate VPC called private net, create a subnetwork in there, but which is very identical in what we set up in the lab net. The only difference is we're going to create a firewall rule that instead of allow, we deny. So we actively deny certain protocols, right? So this is what we're going to do. So I won't show you the GUI equivalent because I've done this already. So we're very quickly going to copy and paste these commands, right? So copy that, go back in here, Control V. So I'm going to create a new VPC called private net. Again, subnet mode is custom, which means that I only create a VPC, no automatic subnet creation at all. So if I go back to my VPC net here, my screen, and I quickly take a, yep, so private net is already up and running at the bottom, as you can see. Right, what's next? Well, we need to create a subnet, right? So let's copy this next line. And again, we've already done this in the earlier part of the lab, so I won't elaborate further. Just go ahead and create that private dash sub. And I come back here and I do a refresh. And the subnet is up and running, right? Now, what's next? We're going to do a firewall. Create a set of firewalls. So this is a firewall. So this is where it gets interesting. And it kind of differs a little bit from what we did earlier, where we allow the ability for you to ping as well as to secure shell in. Now we're saying that, okay, firewall rule create, private net dash deny. The action is deny. So we are actively denying ICMP and port 22. Hit enter, let that firewall rule get created and applied to that subnet. So over here, to verify, I go to the firewall rules section. I should see a third one. There you go, private net dash deny. And that has been enforced, right? Now, we've done all this even before we created the first VM. So that's a good practice, you know, have all the rules there before you put the VM in there. Right, so click to check my progress. Yep, good. So now let's go ahead and create VMs, right? So again, you can create VMs using the web GUI, but again, we're using command line here just to speed things up. So we're going to create a PNet VM and a CNet VM. The P, of course, is private. In C, I think we actually call it L because it's LabNet. So let me go ahead and just quickly copy and paste. You can do the same. Don't have to wait for me. And we just go ahead and create that VM, right? And to know that VM is being created, you go to remember the compute engine page where I asked you to create a tab for. Now you can see the PNet VM is now being set up. And then we are going to go and create a LabNet environment. So let me go ahead and follow this, but I'll do this in the GUI now. So we'll go to Compute Engine, create instance, and we're going to call it LNet-VM in US Central 1C. Okay, so LNet-VM in US Central 1. I want it in Zone C, general purpose. Yep. Stock standard image. Networking, I want to put it into the right network. So that would be in LabNet, correct? It's already verified here, so I don't have to do more, and I click create. And boom, second one is coming up. So let me. Okay, so now we have created two VMs. Now again, you could have copied this and just change the parameters, and you're able to do it, but I wanted to show you how to do it in the GUI. So let's quickly go down and check my progress. We're good. This is the fun part. We are now going to ping, and you will see the firewall in action, right? So now let's go back to the compute. Let's take the external IP. Now your external IP will be different from mine because you're creating your own VMs there. So I'll copy that external IP of LNet, which is the one in LabNet where we allow. So if I do a ping -C3 and put in the IP, you can see that we're able to ping the VM called LNet VM in LabNet VPC, where we've set a firewall rule to allow. So we can ping it at 185 milliseconds. Now we're going to ping the other one in PNet. Copy, Cloud Shell, ping -C3. What will happen is it will not return anything because the firewall rule is now applied and actively blocking my ping. Right? So if we go back quickly, let me. Oops, where is? There you go. Okay. So that concludes the lab. What we can do very easily, I'll just leave everything here. I will come back to this lab and I'll click end. Or you can leave it running till the end of the 1 hour, but since I'm not going to touch on it anymore, I'll just quickly end this, right? And then everything will be reclaimed, right? So what we want to do next, we want to quickly jump to the next lab. So the next lab is here. Let me close all these windows to get rid of the distraction. All these tabs. Yep, bye-bye. Okay, so you go to the top of your Qwiklabs and you type in HTTP load balancer and hit enter. It will return a number of labs. We are interested in a third one called HTTP load balancer. You click into that. Now, if you want to follow along, go ahead and click on the green button. But in order to save time, what I've done is I have created a project of my own sitting outside of Qwiklabs. So Qwiklabs can create a GCP environment for you, but you, with a valid credit card, can go and create a GCP account. Now, this GCP account and project will be available to you 24/7. When you sign up for the very first time, you get $300 US free in credit. So until you use up the $300, then we will start charging your credit card, right? So that's more than enough money to do a couple of labs and just to showcase stuff here. So the reason why I'm doing it this way is to show you that there's another way of running GCP that's outside of Qwiklabs. But of course, the disadvantage is that, well, not really disadvantage, it's only fair because you're using the platform and so we'll be charging you, right? So there's no free credits. But if you use Qwiklabs, you will get to use the environment for free because we're giving you 30 days free credit. Now, what I've done is ahead of time is I have already gotten a project. I call it the global HTTP load balancer demo. I have a Cloud Shell that I need to reconnect, right? And I've created the environment that basically simulates everything in HTTP load balancer. And I'm going to walk you through that lab in the next 5 to 7 minutes, right? So here we go. So everything here, the first part is exactly the same that we talked about previously, where we talk about setting up, clicking the start lab, creating the Cloud Shell, understanding the environment. So we'll skip all that. So then we click to create a network and HTTP firewall rule. Now this is already very familiar to you because this builds upon the first lab. So we don't need to explain too much except to say that we're going to create a VPC called HTTP LB, and the subnet mode is auto. It is not custom this time. So it is going to create a subnet in every single region around the world where GCP has a presence, right? So that means if I flick back to this and I go to the VPC tab, you will see that I have created a HTTP LB, right? And it has a subnet around the world. So that makes it easy for us to deploy a VM and to try out how load balancing would work, right? So that part is done, all right? And then what's next? We are supposed to create a managed instance group. Before you can create a managed instance group, you need to create what we call an instant template. So what I've done is I've already pre-created that. So if you go into your compute engine tab, right? And instead of the first one where we see all the VMs, you go to instance templates. You will see that I have gone ahead and created 2 templates. Now in this, again, this is a very simple illustration. There is not much sophistication. You can do a lot more customization in your instant template. So what this means is that you're not creating a VM just yet. You're laying down a blueprint of what your VM would look like and behave, right? Your OS, what kind of startup script would take place. Do I need to copy any initialization files into my VM to make sure that it's working the way I want it to work? You put it all in a template, right? So we're not creating VMs, we're simply putting down a blueprint. Next, we will then create a managed instance group. A managed instance group is a group of VMs that is based on an instant template that you have created before. And in this instance group, you define how many instances of the VM are allowed to run. You have a minimum, you have a maximum. So depending on the load, we will automatically spin up more VMs in response to the load, right? So that's why we call it a managed instance group. So if we go back to the lab here, we have created the managed instance group, right? We have 2 groups. The first group is in, let me see, is in the US East 1. So we call it the US East 1 MIG, Managed Instance Group. We define the location to be multi-zone. So even the region is called US East 1, that's in South Carolina. There are 3 zones. You can set a specific zone or you tell it to do multi-zone. So it will take its own initiative and figure out which zone to put your next VM so that it's redundant, right? So in case a zone goes down, it's not lost, right? Of course, then we say that this is based on this particular template. On this template, we say we want to auto-scale based on HTTP load balancing statistics. So we're not talking about the actual VM CPU utilization. We're talking about how fast is this VM serving up a web page, right? So we say that there's a minimum of 1 instance to a maximum of 2. That's very low, all right? But the default is 10. But again, you will see why we put this very low, so you can showcase the load balancing later, right? We've got a cooldown period of 45 seconds. Because we haven't created a load balancer yet, right? So there is no need for you to do a health check, and we'll come back to that later. So that is the first MIG. The second MIG is very interesting. The second MIG, we're going to create it in Europe, right? So that's across the pond. But what's more interesting is that there is no auto-scaling. So we can turn auto-scaling off and say that in this MIG, you will always only have 3 instances, nothing more, nothing less. Right? So far, so clear? So over here, you can see in my pre-completed lab, I have created a US East 1, and I have created a Europe West 1. You can see the number of instances that are running right now is 3, because I said there's no auto-scaling. In the US East 1, I said minimum 1, maximum 2. Because there is no load, there's only 1 instance. And you can go to the Compute Engine tab, and you can see that there's 1 US East and then 3 instances in in Europe West 1. Right. So now that we set up the instance group, we want to test that the instances are serving up the web page, right? So this is what the web page is gonna show. It's not very sophisticated. It's just telling you, oh, you have hit this server. This is my IP address, etc., etc. Now, next comes the more interesting part, where we are going to create the HTTP load balancer. So in this instance, I have already gone ahead and create a HTTP load balancer in here, right ahead of time. So the details are here. I will go into Edit, and you can see I have added the 2 MIGs. So under the backend service, I created a backend service, and in this backend service, if I click on the Edit, you will see that I've included these 2 managed instance group as part of my backend service, right? So now, as part of my backend service, I would also have created a health check. A health check looks at the individual VMs, and if they're not responsive, I will go ahead and spin up another VM to replace that VM. So I will not go into too much detail on that one. Now, the only thing that you need to be cognizant about as you're doing this lab, when you create your load balancer for the very first time, right? And I will come back to this lab and let's go to we'll skip all this detail. You can follow along. It's fairly straightforward and detailed to a point that you can't possibly misconfigure anything. Take note under testing and monitoring. Your HTTP load balancer might take a couple of minutes until it is accessible. So this load balancer as a service, once you create it and you've done everything right, it may take up to as long as 5 minutes before it starts working. So if you follow along the lab and you are trying to get to this page here, let me see, where is it? Oh no, further up. You're trying to hit the website based on the single IP that's associated with that load balancer, and you get a 404. It doesn't necessarily mean that you've misconfigured anything. So just sit back, relax, have a cup of coffee, wait 5 minutes, and it should be up and running, right? So in this part, I've already got something working, and you can see that the IP address is 35.241.54.100. I'll come here and click refresh. You can see that. Okay, so the global load balancer is working and it's farming out work. So the next part of the lab is for us to create a siege or a load generation VM. So this is the siege VM. It's situated in US West. My own creativity, I've created one in Singapore because I want to see and prove when I create a load in the US and I create a load in Singapore, what happens, right? So click on this one. We'll run a load generation. And again, depending on the speed of this, if I don't have enough time, I'll just quickly come and show you my load balancer in the monitoring page, right? I look at the last 6 hours. So I've been playing with this for the last 6 hours, and I put into my backend service. You can see a breakdown of where the requests are coming from. So remember, I created one in Singapore. That's why you see the little bar for Asia. I created one in the US West, and it didn't show. It's not showing up now because there is no load. But when you do run the load, you will see all this going through and hitting your service. The next thing you can play with is to go in and edit your instance group. For example, this one is 3. We'll fix it at 3. You could easily go into US1 MIG and you alter your maximum from 2 to 4. And you will see a very different picture. Because what's happening here is that because we rate limit the HTTP for the VM, right? There is only so much workload it can do before the load balancer switches some of the US traffic to Europe, right? Now, if you're able to increase the rate or increase the number of VMs, you will see the traffic move back. So that's the exciting part. Now, because of time constraints, we've only got less than 2 minutes left. I will leave this with you to enjoy. Now, remember, you have the labs for the next 30 days, and if you complete everything, you're gonna get another 30 days free. So you have a lot of time. So recap, we've done the first lab, set up the firewall rules, lab 2, do load balancing, and we ran out of time a little bit. But do me a favor, because this is the first time I'm doing 2 labs back to back. We're a bit short of time, but with the whole motivation is to bring more value to you as you attend a live session like this. So if you take up your phone and take a quick picture of that QR code, or you can take a screenshot and you follow the URL link below, it will bring you to an online form, right? Let me go and enable that online form now, since we're collecting feedback. So I'm gonna click, yes, I'm accepting responses now. So if you click on that link, you will go and you will fill in an online form, give us the feedback so that we know what we can do better next time. Now, where can we go from here? Collect as much badges as you want on Qwiklabs as a sign of your prowess. There are a lot of other quests that you can look at, from Windows to Stackdriver to security and identification, and of course, last but not least, certification. And that's the reason why I'm wearing this shirt now. I cleared my cloud architect certification last year, and this is a fantastic swag that I got. I've got the logo here to say that I'm certified cloud architect. I encourage you to do the same. Follow the links here. It will bring you to a page to show you what are the requirements, how to get certified, etc., etc. And with that, and only 18 seconds left, I thank you for the time investment with us today as we went through at quite a speed for the labs. I hope you enjoy it, and thank you for spending the whole day with us. And I'm going to hand this time back to our hosts, Paris and Richard. Over to you, and thanks for watching.